Welcome back. In this video, we're going to find the angle between two vectors. So our objectives here are, one, to find the angle between two vectors, and then second, we will determine orthogonal angles. So our first objective, the angle between two non-zero vectors is the angle theta, when theta is between 0 and pi inclusive, between their respective standard position vectors as shown in the figure. We've got two vectors, vector u and v, and our angle theta is between those two vectors, and then the vector connecting those here is v minus u. This angle can be found by using the dot product. Note that the angle between the 0 vector and another vector is not defined, because we're dividing by 0 here. We can find the angle between two non-zero vectors, u and v, essentially having the cosine of theta equals u times v divided by the magnitude of u times the magnitude of v. And we will go ahead and rewrite that in a different format. Let's take a look at a sample. What am I really talking about here? We want to find the angle theta between two vectors u and v. So we can do that using our formula above. So our cosine of theta equals u times v, the dot product of u times v, so it's a little confusing, 4 times 3 plus 3 times 5, all divided by the magnitude of u times the magnitude of v, is the square root of 16 plus 9 times the magnitude of v is 9, square root of 9 plus 25. So 4 times 3, working in my numerator, 12 plus 15, I get a numerator of 27, all divided by the square root of 25, or 5, times the square root of 34. Now our goal here is to find theta. And we've got our trig function, the cosine of theta equals 27 over 5 times the square root of 34. So I've got the ratio. I need the angle. So going to my calculator, I take the arc cosine of 27 over 5 times the square root of 34. And I can just put that in my calculator. And that's going to equal theta. So if I'm in degree mode, I'm going to get my answer in degrees. And when I do that, and I'm not going to show that in the video, but I get 22.2 degrees. If it asks for radians, have your calculator in radian mode, and it'll give you that answer in radians. And there we've got a diagram of that particular angle. By rewriting the expression for the angle between the two vectors in the form below, it produces an alternative method to calculate the dot product. You'll notice that the magnitude of u times the magnitude of v was in our denominator. So if we multiply both sides by the magnitude of u and the magnitude of v, all we've done here is multiplied magnitude of u times, it's a lot of parallel lines, magnitude of v on both sides. Those cancel, and we get the dot product of u times v equals the magnitude of u times the magnitude of v times cosine of theta. So that's all we've really done here on this page. We've got the alternative form of the dot product. And what this leads to is 5 possible orientations of two vectors. I'm not sure there's anything really groundbreaking here. If you recall your geometry, before we had oblique angles, there's no oblique angles here. Okay, nothing is greater than 180 degrees. So essentially we have a straight angle where we have two vectors that are going in opposite directions. Our angle, our theta, is pi, or 180 degrees. The cosine of theta is going to be -1. We know that from our unit circle. Okay, and so there you go. That's one of the possibilities. A second possibility is we could have an obtuse angle. And obtuse angles are going to be greater than 90 and less than 180 degrees, or theta is greater than pi over 2 and less than pi. And again, knowing our unit circle, the cosine of theta is going to be between 0 and -1. So properties of our obtuse angle. We could have exactly a right angle. So our theta is pi over 2. Cosine of theta is 90. There's our 90-degree angle. And then we could have an acute angle. An acute angle is less than 90 degrees and greater than 0, or in radian mode, right? Greater than 0 and less than pi over 2. And our cosine is between 0 and 1. And then we could have a zero angle. Our vectors are going in the same direction. The cosine of theta here is 1. The cosine of 0 is 1. And our theta, or our angle, is 0 degrees. So in our second sample problem here, given the angle theta between u and v, find the dot product of u times v. Well, they give us the magnitude of u, and they give us the magnitude of v, and they give us an angle theta. So we can use our alternative form here. So if I need to take a peek at my alternative form up here, I can. U times v equals the magnitude of u times the magnitude of v times the cosine of theta. So u times v equals the magnitude of u and v times the cosine of theta. Well, this is just substitute in and go. So the magnitude of u is 4 times 12 times the cosine of pi over 3. So 48 cosine of pi over 3 from our unit circle is 1/2. And 48 times 1/2 is 24. So the dot product of u times v is 24. And finally, orthogonal angles. Essentially, orthogonal angles are angles that are perpendicular or meet at right angles. It turns out that vectors u and v are orthogonal when the dot product u times v equals 0. The dot product of any two vectors is 0, then we know that those two vectors are going to be right angles. Okay, so it doesn't matter where they're positioned. So in sample 3, are vectors u and v orthogonal? Well, let's take the dot product of those two and see if they equal 0. So let's check it out. The dot product equals 0 is our question mark. If they are, then we will know they're orthogonal. So u times v equals 2 times 6 plus -3 times 4. 12 minus 12 is indeed equal to 0. U and v are orthogonal. And there's an example of what that would look like on the coordinate plane. So now we've got a couple more. Determine whether u and v are orthogonal, parallel, or neither. Parallel, we'd need to find the slope must be the same, or tangent. We can just multiply u times v and see if it equals 0. U times v, 15 times -5 plus 9 times -3. We can probably see already that -75 minus 27 does not equal 0. So these are not orthogonal. So let's check to see if they're parallel. So we need to calculate the slope. And let's calculate the slope of u. Now what we'll do here is we will calculate the slope from the origin. And slope, of course, is our change in y over our change in x. So our change in y is 0 minus 9 over 0 minus 15, or 9/15, which is 3/5. And then the slope of v, 0 plus 3 over 0 plus 5, which is also 3/5. So our slopes are equal, and then we know that these are parallel. We will get a little bit more practice with working with the angle between two vectors and orthogonal angles, calculating those things when I see you in class.